probably should talk about just in case a scenario kind of thing. I'm not saying we're going to have a snow day on Monday, but they are calling for some snow on Monday. And you guys know how exams work if there's snow days. Nothing is going to change. Like nothing is getting postponed. If we have a snow day Monday, we're still going to have a review day on Tuesday. You only get one. Reviews are on Wednesday. If you have a snow day on Monday and Tuesday, reviews start on Wednesday, or exams start on Wednesday. This could be our last review day. And then if you ever have a snow day like on an exam day, then everything slides. Does that make sense? So if you had let's say we had a snow day on a Wednesday, Thursday would be first and second hour exams.
So would that Monday be a half day?
Yeah, that would move that Monday would be the 5th and 6th hour exams, and that would be a half day. So, huh?
Not be as huge as math in general.
It's all right. It's done. I don't take offense. You know. So, what I'm concerned about is, all right, we have a snow day on Monday. To me, that means we lose a review day. Now, my plan on Monday is to go over all the graphs again. You know, basically just show, that's the chapter 2, it's the sine graphs, cosine graphs. Based on your test results, you guys did really well on that stuff, so you probably don't need a whole lot of review, unless you're all a bunch of cheaters, and, you know, I don't think that's true. So, but,
I've never cheated so much in my life.
yeah. All right. I do want to go through chapter 1. So, goal today. So, real quick, and I'm going to do this every day that we're here. Any last questions on chapter 8? Logarithm stuff? Anything from the review you want me to go over? Okay. And otherwise, after I'm done asking questions kind of thing, it's kind of going to be a wrap for chapter 8. So, all right, so what do you got? 21 from the review?
Yeah, I just really forgot how to do it.
All right, so it says log base 2 of 6 plus log base 2 of n plus, minus, right? No, of 3. Minus log base 2 of n equals log, it's a weird O, base 2 of 9, right? So what's your properties tell us we can do? We can combine all these logs, these 3. What do you do with plus? You multiply. Minus means we divide. So these 3 can combine to become log base 2 of 18 over n. And now, since we have log of this equals log of that, we can just drop our logs. 18 divided by what is 9? The answer's 2. Anything else from chapter 8? What do you got?
I feel like this one's like really simple, but I just forgot how to do it.
Number 1, type in your calculator. 81 raised to the 1 over 11. Just come out to 1.49. So just type in your calculator. It's number 2, just type in your calculator. Anybody else? Chapter 8, going once. All right. I don't do going twice. We don't need that. All right. Page 5. Way at the back of the beginning of the book. Page 5, Chapter 1. What's up?
Is that what we're supposed to do or something?
Yes. All the summary reviews.
That makes a lot more sense now.
What'd you do?
Well, I had like, you see that?
It's abuse.
Yeah, I don't know what
He's
she
dumb.
just.
He's like telling me all these pages I have to write
So-
down for
You
chapter.
wrote
That wait, what I just witnessed was physical and verbal abuse. Number one, like you threw a notebook at him, then you called him dumb. Like that's both.
Not wrong.
I'm not saying you're wrong.
Madison, he never said you were wrong. He just stated what happened.
Yeah. All right. Chapter 1. Functions. Got to know what a function is, be able to recognize it. Talk about domain and range. Could be a set of points, like if you're looking at page 5, like number 1, number 2, could say, is that a function? Domain, range. Could be kind of a graph, like if you look on page 6, are those functions, those kinds of things. That's honestly all you need to know out of that section. Good there? Okay. And this was a long section, or a long chapter. There's a lot of sections in here. But a lot of it, I think you're going to go, wow, that stuff's really easy. So, section 2, yes, you should be able to do the distance formula. I'll give you 2 points. You find the distance between 2 points. But the biggest thing out of that one, that this is where we introduced x squared plus y squared equals r squared. So, not that that's difficult at all for you, but that is where we introduced that. Yeah, that's really all you need to know out of that section. That stuff should be pretty easy. And then we got into the angles. Yes, make sure you know how to draw angles. I say draw a 310 degree angle. That goes up, can be almost all the way around, kind of right about there. Be able to tell me what quadrant those kind of angles are in, those kinds of things. Positives and negatives, those should be pretty easy at this point though. Coterminal angles. Make sure you know how to calculate coterminals. How do you find coterminals? Add or subtract. I would just say add or subtract full rotations because we're about to talk about degrees and radians. So if I give you a coterminal in radians, you're going to add or subtract 2 pi, right? So make sure you can do those. Yeah, that's really all you need out of that stuff. And then the conversions. You have, so we have degrees. You have degree decimal. You have potential degree, minute, second, and you have radians. Be able to go back and forth basically from any one of those 3 systems to the other. So be able to go here to here and back and forth, be able to go here to here back and forth, there to there back and forth, whatever you need to do. Okay? So any kind of relationship between those 3. If you have a question, gotta ask. Otherwise, I'm just gonna assume, yep, you know how to do that. I would turn it into degree decimal first and then convert it. So so generally degree decimal, you're not really probably going to have degree minute seconds into radians, because that's a little bit uglier of a calculation with decimals. But if you had 123.47 degrees, whatever the ugly decimal is, right? And that could also have started in degree minute seconds where you put it into that. What is the general process at all to go from degrees into radians? Well, we need to add a pi, right? So we got to times it by pi, and we got to divide it by 180. Like that's just going to be the process. So now it's about just cleaning that up. Will that reduce? I don't know. I mean, to clean it up a little bit, you could times it by 100 just to make it 1, 2, 3, 4, 7 pi. But if I move the decimal twice on the top, I also have to move it on the bottom, right? That would be a nasty problem. It might reduce, I don't know. But I probably wouldn't give you something like that. Should? Make that the answer? If I did that, I'd make that a 5 for sure. Yeah. There's no reason to have 1, 2, 3, 4, 7. Yeah. Just make that a 5. Yeah. Okay. There is probably going to be a question like this on the exam, and that's because I know they're also on the SAT. You seen those new TikToks of those teachers doing the perfect circles? Oh, they're way better than me. And I don't know how they do that with their wrist. Like, I tried it. My wrist does not bend like that. Anyway, if I give you 7 pi over 6, is that central angle and the radius is 8? How do you find arc length? What? Times them together. X is just going to equal 7 pi over 6 times 8. Multiply them together. Well, that reduces, so what do you got? 28 pi over 3? And there you go. Moving on. Times them together. What? I do the best I can. I'm not perfect. And by the way, that's one of the largest water bottles I've ever seen. I honestly don't even know. I've never made a TikTok. I just watch them. I'm just kind of a creeper.
We should start making TikToks.
I'm just.
We can get you like famous, like a famous teacher in there.
You get,
Yeah.
no, I would appreciate that. I would appreciate you making me famous, but kind of already am,
Not really. That's boring. Nobody watches.
There is a lot of those on there. Like, I scroll through it about.
Other teachers will watch it.
Yeah. I thought about doing like just little SAT tips and just do like hard problems real quick, but yeah. I already am famous. Let's see, chapter 1, skip that stuff.
So if I can find it on TikTok,
Is that a thing on TikTok?
I think so. I don't know, like follow me or something.
Yeah, you can follow each other.
Yeah.
Okay.
Follow you, Mr. Tank.
All right. Next thing on. What's sine equal to? Y over r. Cosine is x over r. Tangent is y over x. Cosecant r over y. Secant r over x. And cotangent x over y. And then x squared plus y squared equals r squared, right? Now, on the exam, remember when we did these problems in the book and on the test, I gave you either a point, right? I said the point negative 5, 3, so I gave you an x and a y, and I said, what's all 6 trig function? You had to write all 6, right? Or I gave you sine and said, what are the other 5? Your exam questions are not going to be that. Probably. We'll talk about that. It depends on the snow. On the exam for these types of questions, I'm just going to ask you for one of them. So I'll give you this and say, what would secant of theta be? Well, secant is r over x, so I don't know the r, but I do know the x, right? So you just got to use x squared y squared r squared to find the x that goes with it, or the r that goes with it. Make sense? So, you know, it's not going to be all 6. It's just going to be what's one of them. Because, yeah, multiple choice, it's just easier to do it that way. Fair enough? You have to know. Oh, and with these, another thing I can do here that would make it a little easier is, you need to know this. Again. And no, there's not going to be a non-calculator portion of this, but I do have some creative ways of asking questions where if you know this, it will make your life a lot easier. It could be a question like these with the x, y's, and r's. And I just say, well, if cosine is square root of 3 over 2 and I'm in the 4th quadrant, what's tangent? Well, that's a 2. If cosine is square root of 3 over 2, well, that means I have a 30-degree reference angle, right? And I'm in the 4th quadrant. Well, tangent is 30 degrees would be root 3 over 3. In 4th quadrant, tangent is negative. Done. Do I have to do the x, y, r stuff? No. If I knew my table, I could get the answer real quick. So, yeah. You're going to want to know your table. You're going to want to know your quadrants. And you're going to want to know the quadrantals. Do I need to fill it in, or are you guys good? All right, I'll fill it in. What's sine of 30? 1/2. Root 2 over 2. Root 3 over 2. 1/2. Root 2 over 2. Root 3 over 2. Root 3 over 3. 1. Root 3, right? Sine's positive in the top 2. Cosine's positive in the right 2. Tangent, 1st and 3rd. What's sine of 0? Think about the graph of chapter 2. Think about the sine graph. That can help you with this. Remember, doesn't all our sine graphs look like this? What's sine of 0? Where does it start? Starts at 0. And it goes up to 1, right? And then it goes back to 0, negative 1, right? Starts at 0, goes up to 1, 0, negative 1, 0. So after you now know the graphs, it also should help you here. What does the cosine graph start at? Starts at 1, doesn't it? Doesn't start at the peak. And then it comes down to 0, negative 1, back to 0. After you know the graphs, that should be a little easier. Tangent goes 0, undefined, 0, undefined. Did you say negative 0? What's wrong with you? The difference is it doesn't exist. No, you're saying a number that doesn't exist. To me, saying negative 0 is the equivalent of saying 0.9 repeating. Because the number 0.9 repeating does not exist. That is not a number. Because it actually does equal 1. Like those are the exact same number. It's not that they're close. It's that they actually are equal to each other. Nope. I can prove it to you in multiple ways, but that is an absolute fact of life that this number, just like the number negative 0.
Take a look. Negative 0 equals 0. You're wrong. Go ahead.
So what your calculator just did was basically negative 1 times 0, which equals 0.
Negative 0 equals 0. No, you're just upset.
You're not going to prove that 0.99. Yeah, because I plug that in my calculator.
Okay, would you agree that this is true? 0.3 repeating plus 0.3 repeating plus 0.3 repeating would equal 0.9 repeating. Would you agree with that statement? Great. This is a fraction is? Ha! What do you know? Huh.
You said multiple ways.
I don't want to do it the other way until we get to the chapter about geometric infinite series.
Okay. Anyway, negative 0 equals 0.
Agreed? Just keep adding another 9, moving it over at a 9. So that means you can use a geometric sequence, which the formula is S equals A sub 1 over 1 minus R. 1 minus R. The A sub 1 is 0.9. The R we're multiplying by 0.1. You end up with 0.9 over 0.9, which is 1.
Well, I just did like 3 did this in my calculator and added all 3 of them together.
So what you're saying is, I'm smarter than your calculator.
Okay, so...
I'll take that. Yeah. Okay. By the way, that stuff's not going to be on the exam. Okay, everybody look at page 50. 50. This will be on your exam. You need to be able to use your calculator to calculate any trig function of any angle in degree or in radian and inverse. So sine of 72 degrees, cosine 7 pi over 3, secant of 110 degrees, cosecant 7 pi over 2, and then sine of what angle equals 0.713, cosecant of what angle equals 0.413 or 1.413. You need to be able to type all these in your calculators. Anytime you type in an inverse and you're looking for the angles, how many solutions should you have? 2. Because you got to know your quadrants. This is a positive, sine's positive in the top 2 quadrants. I better have an answer in the first and the second. Secant is sine, that's positive, first and second. unless you have a question similar to number like 53, where inverse tangent, there's two answers to that. There's an answer in the first and an answer in the third. And then it also says sine is positive. Well, sine's positive in the top two, so I'm only looking for the top answer, like the first quadrant answer. So there will be those. You will need to know how to calculate those. Degrees, radians, and then the inverse ones as well. Generally speaking, everybody does pretty well with those two, right? How do you type in secant of 110? 1 over cosine of 110, right? Generally, everybody does pretty well with this. You just press the second sign, inverse sine of that. What do you type in for the inverse cosecant? Inverse sine of the reciprocal. So remember, if it's an inverse, if you're dealing with a reciprocal function, you must take a reciprocal. If it's an inverse, the reciprocal goes on the inside. And again, should be two answers. Yes?
So for like the cosine and sine was great.
Yep.
Can you just switch your calculator and radians?
You could. You could switch it in radians and type it as exactly the way it looks. Or leave it in degrees and type it in, but don't type in the pi. You'd put in a 180.
Okay.
Either one, you should get the same answer.
Okay. Thank you.
Yes?
So for to find the angle, the sine, to find the two answers, is one just negative and one positive? Or
No, it should just be, what two quadrants am I looking for here? It's a sine and it's positive. I need an answer somewhere between 0 and 90. And then I need one in the second quadrant, so it's got to be between 90 and 180. So now we're talking reference angles. So if, this one I would type in, gotta make sure I'm in the right mode. I would go inverse sine of the 0.713. So my first answer is 45. How do I get to the second quadrant? How do I always get to the second quadrant? 180 minus that. So there's my two answers, 45 and 135. How do you get to the third quadrant? 180 plus. How do you get to the fourth quadrant? 360 minus, right? So it's all that stuff. Are we good with that stuff? Chapter 1, honestly, I'm hoping you think it's all easy. And now you're going, man, that was so long ago. I kind of remember doing that, but it just seems so easy at this point because we haven't stopped using that. We kind of went away from doing the inverse stuff for a little while, but lately we have been using a little bit of the inverse stuff with solving the triangles, right? And yeah, we're going to do more of that in the near future again, so that's not going away. And once we keep using these skills, remember when I taught this chapter, I kept saying this is foundation stuff. You had to understand how to do this so we can keep going farther. We're going to do a whole chapter basically on inverse stuff. So the whole inverse sine, inverse cosine, we're going to do a lot with that. We still have a lot to do with that stuff. And that's coming fairly quickly. I think that's chapter 5. So, or no, that's chapter 6. We skipped chapter 5. Yes? We're skipping.
I did the chapter 1 review yesterday.
Yeah.
For number 16.
Chapter 1 review number 16. Okay.
Do you just type that in your calculator?
For the last one?
Yeah. Or do you?
That one I would just say, so basically what you're solving is it says cosecant of theta is equal to negative 2.2023. And it just says I want my answers between 0 and 360. So what do I type in my calculator? This is a reciprocal function, so I have to take a reciprocal. It's inverse, so it goes on the inside, so 1 divided by negative 2.2023. Oh, it gives me a negative 27 degrees. Well, a negative 27 degrees is right here, which is in the quadrant I want. I just don't want that answer. So how do you get the answer you want? You add 360 to it?
Okay.
So there's my fourth quadrant answer, 333. What other quadrant am I looking for here? It's cosecant, which is sine, and negative.
So the bottom.
So bottom two, right? So now I need an answer in the third quadrant. How do I get to the third quadrant? 180 plus the reference angle. What's my reference angle? 27. So I got to do 180 plus, I would type it in as minus because it's negative in my calculator. Minus a negative is plus. And it's 207. So the two answers to that question are 333 and 207. Anything else? All right. If we do have a snow day on Monday, here's what I'm going to ask you to do. Try to have this done if you're not already done by chapter 8. If you're not already done with chapter 1, finish that tonight as well. If we have a snow day, try to get through all the graphs of chapter 2. That's my plan on Mondays. I'm just going to be talking about the graphs. Keep in mind as you're drawing the graphs, the exam is going to be multiple choice. So what does that mean about all the graphs? Are you going to have to draw a single graph? No. What does that mean about the types of questions do you think will be on the exam on chapter 2? Which graph matches? Or what other kinds of things could I just simply ask? What's the amplitude? Like here's an equation. What's the amplitude? What's the period? What's the phase shift? What's the vertical shift? Here's a graph. Which equation matches this graph? Those types of questions are really what I'm going to ask about chapter 2. So I would say if you can draw all the graphs successfully, the types of questions I'm going to ask about chapter 2 should be pretty easy. Okay? So try to have that done. I'm assuming we will have at least one more day of review. I don't think this is supposed to be that crazy of a snowstorm. So I do too. I want some snow. Chapter 3, I don't think we need a lot of review on that, but we'll do that on Tuesday. And that's that.